Hello, everyone, and welcome back to EGR 151 Electrical Machinery. In this unit, we're going to be talking about static electricity. We're going to be talking about some of its applications, some of the nuisances, issues associated with it, or even dangerous issues, and how we can quantify it. So the objectives of this unit, or what we're trying to accomplish in this unit, is to understand static electricity, the very nature of it, why it exists, how it's formed, etc. One of the key areas where static electricity is potentially problematic is with lightning. So how do we protect equipment, homes, etc.? There are, of course, issues. They're just nuisances associated with static electricity that we can understand. But there are some important applications where we use static electricity in manufacturing processes and other types of important useful processes where it's beneficial. So as you're probably familiar, static electricity is around us all the time and occurs in your everyday life. If you ever walk across the carpet and touch something, got a zap, that's static electricity. Happens getting in and out of your car seat oftentimes. The static cling from your clothing, particularly when it comes out of the dryer. And of course, the big area where static electricity is very visible is, of course, with lightning. Lightning is a application of static electricity. As I said, static electricity can be a nuisance. Anyone that's ever tried to pull on clothing, particularly any type of polyester clothing, fresh out of the dryer, you'll find that the static cling is a big issue, and it can even be very dangerous. The fact is, nearly 50 people are killed every year in the United States from lightning. Hundreds of others are hurt, and of course, many, many more around the globe. Now, it turns out, though, that static electricity can be beneficial, and there are a few different processes that actually take advantage of it. Many air cleaners, particularly designed to remove dust from the environment and small particles, also referred to as precipitators, use static electricity. We'll show you that one. Sandpaper manufacturing use static electricity. And if you've ever used a copy machine with toner, right, that's one where the static electricity is used to put the toner down in the specific parts where your copies are made. So static electricity can be used to clean the air around us. For example, this is a precipitator or an electronic air cleaner. The way it is set up is it has a set of charged positive wires. The air passes over this. Any of the particles in the air or precipitate in the air will get charged, get a positive charge. Then as it goes through these plates, they have a negative charge. And as we know from the law of charges, positive and negative charges are attracted. So that dust and different particles will then stick to these charge plates and take them out of the air, thus cleaning the air. Another technique that uses static electricity is the manufacture of sandpaper. If you've ever wondered how they were able to get such a fine, thin layer of sand so uniform on sandpaper, obviously if you ever tried to glue anything down, any kind of particles down, it's hard to get them very flat. They tend to be lumpy, etc. Well, the way this works is we have a positively charged cylinder. The sand is dropped onto this and it forms a single particle layer, which is then deposited onto moving adhesive paper. And the positive charge is then imparted onto the surface, so that guarantees our nice uniform layer of a single particle all the way across. Then, of course, the adhesive paper has to be cured, oftentimes heated, etc., to finalize the process. By the way, a similar technique is used in copy machines to posit down toner. So the paper is given a charge, a static electric charge in the various areas where we want the toner to stick. It then is so the toner is applied, it's then heated, and that's actually what forms the color, and oftentimes black and white, I should say, of the toner on a photocopier. Now, if we get back to our conversation of static electricity, keep in mind it is referred to as static electricity, meaning it's not moving. So essentially, these electrons are going to be building up, and they're going to be generating a charge. Keep in mind, they're not generating current. If they're static, they're not moving, so there's no flow. And it's going to be built up on some material that is insulative, right? So that's why when we walk across the floor or something like that, it's built up on us. When you hit something that's conductive, like a doorknob, then the charge is discharged. Now, as long as it's just an insulator, though, it will hold the electron stationary. And keep in mind, they can be both positive or negative charges. They don't have to be one or the other. Now, the place where we see static electricity in its rawest form is, of course, with lightning. This is when the charges are built up in the clouds. They're built up on the surface of water drops. Interestingly enough, they're not necessarily positive or negative. It's one or the other. If they're large drops, they will tend to become positively charged, while smaller drops will tend to become negatively charged, right? And they even can be in the same cloud. You can actually see that when you see lightning jumping within a cloud. And the fact is, almost all the lightning that we see that actually occurs inside clouds. Only a small fraction of it actually extends out of the cloud. But those are the parts that we tend to see more often than not if you're on an airplane or something. So if you take a look, generally you're going to have our positively charged material up here, right? That's going to be at a lower temperature, right? And the cold air is going to tend to drop down. Warmer air is going to have smaller particles, tend to be of negative charge, and so we can have both positive and negative charge. In addition, of course, the Earth itself can become positive or negatively charged depending upon the material. For example, if it's a conductive material, non-conductive material, organic material, etc. If you get enough of a potential, you're going to have an arc, right? That can be potential between clouds, or it can be between a negatively charged cloud and a positively charged ground, or the negatively charged ground and a positively charged cloud. You'll notice, though, it'll always travel from the negative to the positive, whether that's from cloud to cloud or from cloud down to tree, etc. Now, of course, we don't want our homes to be hit with lightning. The higher something is, the easier it is to be hit by lightning. So many buildings are equipped with a lightning rod or other form of lightning protection designed to take that strike and carry it to the ground instead of having it pass through the building itself. Right. Other nuisance charges that we're going to deal with is, of course, as I said, the clothes dryer, walking across the carpet. If you're in a vehicle and you're moving through dry air, that'll happen. And you'll notice as you get out of your car, as soon as you touch something metal, you get a shock. So those are all the kind of nuisance ones. Not dangerous in any way. They're just kind of shocking, etc. Now, where else can we use static charges? Well, as I said, we could use copy machines. Those are done. We also use them for spray painting. If you want a fine, thin layer of relatively very strongly bonded paint, you can run that through a grid similar to what we did with the air going through for the air cleaner. And if you keep this positively charged and our object negatively charged, the paint will be sucked right onto that. So static electricity is used for spraying these materials. Gives a very strong bond, very even paint job. Now, in summary, pretty straightforward. Static means that something's not moving, right? And we're going to either have positively or negatively charged ones, depending on if there is electrons removed or excess electrons. Static charges always are going to accumulate on an insulated material, right? And then lightning or any other type of static discharge is going to be when it reaches a certain amount, and there's enough there to cause it to jump. Right. So, quick conversation about static electricity. As always, if you have questions, don't hesitate to ask. Definitely take a look at the course space and, of course, read your text for additional information on static electricity.